Okay, so the last place we're going to check, okay, the last position we're going to check at Z is equal to 3.2 meters. Okay, 3.2 meters. So then you have to consider your shear force is equal to minus 40 times 10 to the power 3 Newton. And your moment at that stage is going to be at 32 times 10 to the power 3 Newton meter. Right. So the normal stress, again, we check stress X. Now this is Z is equal to 3.2, okay? So stress in the, wait. Yeah. I think I've been messing up with my, it's not stress in the, it should be in the Z direction. Okay. So I got this wrong. Okay. So normal stress in the Z direction. So the moment now has been moved to 32 times 10 to the power 3 divided by 40.1 times 10 to the power minus 6. Okay. Multiply by 0.259 over 2 minus by 0.01. Okay, so this will be equal to 0.259 divided by 2 minus 0.01 times by 32 power 3 divided by 40.1 power minus 6. So it's equal to 95.362 times 10 to the power 6 Pascal. Okay. Then we calculate our shear stress, right? The shear stress. So now the shear is at 40. Okay, so you take 40 times 10 to the power 3. The first moment of area did not change, okay? So the first moment of area is 126.99 times 10 to the power minus 6. And then divide by I. And then the thickness is, what was the thickness? 6.35. All right, so this will be equal to 6.99 power minus 6 divided by 40.1 power minus 6 divided by 6.35 power minus 3. So it's 19.949. Okay. So now we have 3 positions, right? All the value. So the only thing that we don't know is we don't know the principal stresses at point at when Z equal to 0.8 and Z is equal to 3.2. But we know that Z is equal to 2.4. We know that this is 143.042 times 10 to the power 6 Pascal, which is the principal stress because the shear stress is equal to 0, right? So now let me try to draw into context how to use Mohr circle now, okay? So if you look at the element now, so now I'm drawing the element, okay? So this is your Y, this is your Z direction. So when we construct our element, right, we know that, let's say we consider Z equal to 3.2, okay? So we know that there's a normal stress either going out or coming in, does not really matter. We know that there is one as 95 0.362 times 10 to the power 6 Pascal. And we know that there's a shear. Okay. Again, does not matter whether is it positive shear or negative shear. Now here I just draw negative shear. Okay. So this is 19.949 times 10 to the power 6 Pascal, right? So if we are going to sketch up Mohr circle, I'm going to sketch this. Okay, this is just a sketch, by the way, right? Two D Mohr circle. Okay, later on after today you can do 3D. Right. So we know that this is normal stress. This is shearing stress clockwise, shearing stress anti-clockwise. So this is our point Y. This is our point Z on Mohr circle, right? So we know, okay, we know that over here, again, this is just a sketch. Okay, so this is your stress Z line. This is your stress Y line. Okay, and then you have your shear. Right, this is your shear line, right? And this is your point Z, and this is your point Y, right? So now we know that it intersects from here to here, right? So now we can draw a circle now, okay? So you can construct a Mohr circle. Right? So now we have to find this point. Okay, we have to find what is our stress 1, and then we have to find our stress 2. Stress 2 is not so critical, right? Because stress 2 is very close to the zero stress line. Okay, so now we have to find. Okay, we have to find stress 1 and stress 2. Okay, so it's not that difficult, right? So we now find the. Okay, we have to find the principal stress. Right? So we know that center of circle, which is your stress average, is equal to 0 plus by 95.362 divided by 2, right? So 95.362 divided by 2, so it's 47.681 megapascal, right? And then you find the radius of the circle, okay, which is your tau max. So this will be equal to 95. Will be equal to 95.362 minus by 47.681 squared. In fact, it's 48.681. What am I doing? Anyway, then plus by the shear, which is 19.949 squared, and everything is in megapascal. So this will be equal to 5.36. squared times by 19.949 squared. Square root is you get 951. Wait. 95.362 minus 47.681 equal squared plus by 19.949 squared. Square root 51.686 megapascal. So stress 1 and 2 is equal to 47.681 plus or minus 51.686, right? So the value is 41.681 plus by 51.686 is equal to 99.367 megapascal. So these are the principal stress, or 47.681 minus 51.686 is equal to minus 4.005 megapascal, right? So if you look at 99.367, right, it's at point Z is equal to 3.2, okay? And it is less than Z is equal to what? 2.4, right? So by looking at the values down here, by right, we should check at point Z is equal to 0.8, okay? We should check it, okay? But because of time, I'm not going to check it, okay? But you have to in the exam, if this is asked, okay, you have to check, okay, to see what is your principal stress. But I know it will be less than 143 because these two values, okay, are no means going to generate a principal stresses that is okay. Rather than talking about it, let's check, okay? let's do it. So it's the same thing. So if we apply our stress average, right, our stress average is equal, or center of the circle, right, which is our stress average. So this will be equal to 47.681, right, plus by 0 divided by 2. So 47.681 divided by 2 is equal to 23.841 times 10 to the power 6 Pascal. So the formula is still the same, right? You get the center of the circle, then you find the radius of the circle. Right, so I'm just going to do directly 23.841 squared plus by 39.897 squared. Okay, so 23.841 squared plus by 39.897 squared, square root, you get 46.478 times 10 to the power 6 Pascal. So stress 1 and 2 is equal to 23.841 times 10 to the power 6 plus or minus 46.478 times 10 to the power 6. Okay, so 23.841 power 6 plus 46.478 power 6. So it's equal to 70.319 times 10 to the power 6 Pascal, or 23.841 power 6 minus 46.478 power 6, 22.637 times 10 to the power 6 Pascal. So it's less. So the least likely place to fail is at 0.8 and at 0.4. Z equal 0.8 and Z equal. So the fail is going to fail at where? It's going to fail where Z is equal to 2.4, where you have maximum bending moment of 48 Newton meter. So again, then you check the 143 times 10 to the power 6 principal stress with the allowable. So if you look at the allowable is at what? 160, right? So if the allowable is 160, your maximum is at what? Your maximum is at 143.024. Basically, your factor of safety is equal to 1